This evening we are going to talk about the first uniform equation of motion and average acceleration. Acceleration is defined as the rate at which a velocity changes over time. So for example, if I was talking about a cyclist accelerating at a rate of 0.5 meters per second squared, this means that for every second, the cyclist's velocity will be increasing by 0.5 meters per second. It's important to note that acceleration is a vector quantity. This means that you can have a negative acceleration, but we're going to bookmark this and we're going to talk more about it tomorrow. So the first uniform equation of motion compares the change in velocity to the change in time. Over here, I have derived the units for acceleration. Velocity's unit is meters per second. Time's unit is seconds. This means meters per second times the reciprocal 1 over seconds. So the units for acceleration are meters per second squared. It's a derived unit. So please write this equation down into your notebooks and define your variables. Label this equation as the first equation of motion. A equals delta V divided by delta T, where A is acceleration in meters per second squared. Delta V is the change in velocity. Final velocity minus initial velocity. Remember, this is the symbol for initial, so V naught. And delta T is the change in time. So since we always assume we start the clock at 0, we assume that the change in time will always be equal to TF, or the final time. Pause the video at this point. Make sure that equation is in your notebooks. So at this point in time, we're going to work through an example problem. The example problem says that a car is traveling in a straight line and has a velocity of positive 5.0 meters per second. After an acceleration of 0.75 meters per second squared, the car's velocity is positive 8.0 meters per second. In what time interval did this acceleration occur? So let's take a look at our equation. Again, good rule, always write down your equation first. So A equals delta V divided by delta T. Next thing I'm going to do is I'm going to rearrange this equation to find time, because that's what the problem is asking me to find. So I'm going to multiply both sides by delta T, and I'm left with A delta T equals delta V. Divide both sides by A, and I am left with delta T equals delta V over A. Now it's just time to fill in my variables. I have final velocity, 8.0, minus initial velocity, 5.0, all divided by the acceleration of 0.75. And then, so hopefully there's not too much of a break in the video, but what we just did was final velocity 8.0 meters per second minus initial velocity of 5.0 meters per second divided by an acceleration of 0.75. And then what we get here with proper sig figs is an answer of 4.0 seconds. 2 sig figs once again, because there are 2 in my initial velocity, 2 in my acceleration, 2 in my final velocity. Hopefully this helps you solve the problems on page 49, 1 through 5. Have a good evening.